All right, so we begin at the top of page 177 with the objective. And can we go to everybody on page 177? Amy, can you read the objective, please? Thank you. All right, let's try number 1 together. X times x, what does that simplify to? That's x squared, yes? That's the definition of x squared, right? Is x times x. Okay, the next one looks kind of similar. What's the change? It's now a plus instead of a times, but it's a completely different answer. What is x plus x? 2x. How about the next one? X minus x. Is it negative x? Is it 0? Undefined? You've given me like 3 different answers. Olivia has stronger feelings towards 0 than any of the other answers. What do we think? X minus x. 0, right? You're subtracting something from itself. We get 0. And then finally, x divided by x. Olivia has an answer, but she had lots of answers before, so we have to. What do we think? A number divided by itself is 1, right? 5 divided by 5 is 1. Pi divided by pi is 1. Okay, so in all 4 examples, we had x, and then each of the possible operations in between. 4 completely different answers, but we got to be really clear about which one is which. Let's take a look down here at number 2. Simplify 5x times 2x. Now, there are lots of wrong ways to go about doing this, and there's only one right answer at the end. Amy?
10x squared.
Amy says 10x squared. Any other thoughts? Any other possible answers? 10x. I actually want some wrong answers to come out. So just if you have other ideas for what this might be, I want to hear them because we want to make sure we see what the possibilities are and then make sure we find the right one. Other possibilities? Is 7x a possibility? No. In order for 7x to be the answer, what would the question have to be changed to? Make it 5x plus 2x. Okay, so it's not that. So I'm glad we see it's not that. Okay, so I'm going to do something that is completely optional for you. We're just going to do it. You guys agree that 3 times 4 is the same as 4 times 3, right? And we had a fancy name for that. It's called the commutative property of multiplication. It says you can multiply 2 numbers in any order. Doesn't change anything. So I'm gonna rewrite this guy right here. I'm gonna copy the 5x times, and then I'm gonna swap the x and the 2. So x times 2. Is that fair? In fact, I'm not gonna do that. What I'm gonna do instead is put the 2 and the 5 together and put the x and the x together. So I've done a few different swaps, but the point is when you're multiplying numbers together, you can multiply them in any order you want. And so what I've chosen to do is group the numbers together in the front, the 5 and the 2, and group the x's together at the end, but it's all straight multiplication. It was multiplication before, so I haven't changed anything. And now we're going to choose to mush together the things that go together. 5 times 2 is 10. X times x, we've seen, is x squared. So this one is 10x squared. Okay, so we're just going to put a little line through here, but I'm glad that we had 10x on the board because it's very tempting to say that it's 10x. Again, it's totally optional for you to rearrange the terms, but until you're comfortable, I'd encourage you to rearrange the terms. Okay, number 3. X times x plus x times x plus x. Okay, now we still have to follow the order of operations, PEMDAS. So what needs to come first? We need to handle the multiplication first. So x times x, what is that really equal to? That's x squared. We've seen that already. Then the plus is just waiting because plus is way down at the bottom of our list in terms of the order of operations. There's another multiplication. That one's another x squared. Plus, and then this x, there's nothing to do with it at the moment. Okay, now for the first time we have x squared plus x squared. And again, there are a lot of wrong ways to go about doing this and only one right answer, but I'd really love to get some of the wrong answers up here. Amy. Everybody see what Amy's doing? She says, I see x, and then I see 2 and 2 and an invisible 1 on that last x. So maybe x to the 5th. Good. Other thoughts? X to the 4th plus x. How did you get x to the 4? So just add the 2's, but the last x we'll leave off on the side. Other thoughts? As simplified as we can get.
I'm not sure if it's 2.
I'll just put them both. So we have 3 x terms up here, so maybe there's 3 in the front of our answer, and it's not really clear how to get the exponent, but maybe we can get the exponent somehow. Other thoughts? Okay, so I'm just going to remind us of a little bit of work that we did a while back with these algebra blocks. You guys remember we talked about combining like terms? These little guys right here, I don't know if you can see them in the back, but what did they represent? These weren't the x's, these were each 1. Right? And so we just added them together. We said, oh, we have 2. And then we had these rods, and the dimensions of the rods are supposed to be 1 along the top because it matched the same. This was like a 1 by 1 by 1 cube. And so this was a 1 along the top, and then x is what we called the long side right here. So we just thought of this guy as being x. But what we didn't play with was this thing. How long is the long side of the rod? We call that x. These guys match up. So how long is the side of the square here? That's x. How long is the top of the square? X. What do you think this thing represents? This is an x squared. It's actually a volume that's happening here. The volume of this 1 by 1 by 1 block is 1 times 1 times 1, which is just 1. The volume of this guy is x times 1 times 1. That's x. The volume of this guy is x times 1, which is x squared. So up on the board, we have x squared plus x squared plus x. I have little cubes, I have rods, and I have square looking things. What am I grabbing for the x squared? I'm grabbing a square. What do I get for the other x squared? Grab another square. What do I grab for the x? I'm grabbing the cube or the rod? Grab the rod. So what we have up here in front of us is these 3 guys added together, yes? What are you really going to be able to say about adding these 3 things together? There are 3 of them. Which ones can get added together? The x squared guys. So how many x squareds do we have? We have 2 x squareds plus 1x. Can I add these together and say I have 3 somethings? No. So 2x squared plus x is the answer. This is equal to 2x squared plus x. And we cannot go any further. You can group together the x squared terms because physically they look like exactly the same shape. If you want a more mathy way to think about it, it's exactly the same power on each of these x's. That makes it so that you can add them together because they're represented by the same shape. But this plus x is a completely different shape, and there's no way to mush it together with the x squareds. We just can't add it in there. So that's our final answer right there. I'm going to put a little line through all of these very valiant efforts. 2x squared plus x is our answer. Okay, let's take a look at 4, which says simplify this thing. 5 times 3x cubed y squared. Okay, order of operations. PEMDAS. What's the P? Parentheses. I do see parentheses, there's nothing to clean up inside of there. I can't do anything in the parentheses. So I move to the E in PEMDAS. What's the E? Exponents. So I have to handle that too before I handle the 5 sitting in the front. The 5 sitting in the front is associated with what operation? Multiplication, which is further down. It's just below the exponents in our list. So we got to handle that exponent first. So I'm going to write something again, completely optional, but I encourage you to write it until you get comfortable. 3x cubed y squared really means 3x cubed y times 3x cubed y. Agree? That's what squaring something, thank you. That's what squaring something means. Write it twice, multiply together. Okay, now I'm going to write another completely optional step. 5 times. I'm going to start rearranging the multiplication so that all the things that look similar are together. So I see a 3. I see another 3. I have grouped all the numbers in the front. In fact, sorry, I'm not there yet. That's the next step. What I see is x cubed. What does x cubed really mean? X times x times x. Yeah? What's sitting after the x cubed is y times, and then I've got the other parentheses, 3. X cubed is still x times x times x, and there's a y sitting there at the end. Okay, so now for the completely optional step right here, I'm going to group all the numbers in the front. 5 times 3 times 3. I'm going to group all the x's together. And then I'm going to shove all the y's at the end. Okay, so now we're going to write our final answer. 5 times 3 times 3, 45. What's another way to write x, 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 x? X to the 6th. Right? You're just counting. How many x's do you have there? You have 6 of them. What's another way to write y times y? Y squared. Okay, if you take an algebra class after this one, you're going to be introduced to all kinds of rules that help you handle exponents, and they make it so you don't need to write all this stuff out. The goal for here is not to try to memorize rules that don't have meaning, but to try to give meaning to the rules so that when you see them, you'll have a context to place them in. Yes, this takes longer than writing, than just using these rules that you guys are going to see. For example, when we get here, x cubed and x cubed, is there an easy way you can see to just say, oh, that's going to be x to the 6th at the end? What's the trick? Is you add those exponents, 3 and 3. That's why there are 6 of them. Okay, fine. But I don't want you to memorize that rule, because if you don't have a lot of practice just kind of writing it out and understanding why adding is the right thing to do, you might just as well mess up the rule when you try to apply it. Going back to even the very beginning of the problem, is there something you can do with that 3 and that 2 to get our final answer of x to the 6th? You can multiply them. Okay, sometimes we add the exponents, sometimes we multiply the exponents. There are other cases where we subtract the exponents. The point of this right now, this semester, is not to like memorize all of these rules, but to try to understand exactly what's going on with these exponents. And then the shortcuts next semester will have more meaning to you. Okay, last one here, and then you guys will do the classwork. Evaluate x squared plus x plus 3 squared minus x when x equals -5. So evaluate just means substitute, right? Plug in x equals -5. So we go -5 squared plus -5 plus 3 squared minus -5. Okay, I have written something up here that is false and will change the answer to the problem. What did I do wrong? I made an error of omission. Did I leave out? Where should there be parentheses? Around that -5. That -5 needs to be in parentheses, because without the parentheses there, it looks like I am squaring what? What am I squaring according to what's written right now? I'm squaring 5. That's not what I should be doing. I should be squaring -5. But instead I'm squaring 5 and then sticking a negative in front of it at the end, and that's not going to give me the right answer. So we need to square -5. Square the number. Yeah, so when you square -5, what do you get? You get +25. But without those parentheses there, I would have gotten -25. Okay. PEMDAS says handle the parentheses first. So what do we get inside? -2. And what's a better way to write subtract -5? Is +5, right? Two negatives right next to each other. Change them to a positive. Okay, equals 25. All right, -2 squared. That's +4. So that's +4 plus 5. So 34 is our answer. Questions on that? Okay, so start the group work. We will come back together as a class in a few minutes, but let's see how far you guys can get in the classwork first. So let's take a quick look at 3 because this one's challenging. All right, here's one of the main ideas for today. If you see something squared, write it twice. So this one right here, I see a 2, I see WH, I see WH. Agree? WH is being squared. And as soon as but what wasn't squared? What wasn't being squared in this problem was the 2, which is why there's just a solitary 2 as opposed to another copy of the 2, right? Just WH is squared. And then we say, okay, that's 2, and then W times W is W squared, and then H times H is H squared. So 2W squared H squared. That's the answer to that one. Let's take a look at this one. What's being squared in this case? 2 and W and H. So we write the whole thing twice. Yes? It's almost the same as the one that we just did, but in this case we have another copy of the 2. 2 times 2 is 4. W times W is W squared. H times H is H squared. Okay, let's jump down to the bottom right one here. What's being squared in this case? 2W. So we put another copy of 2W, and what's still sitting at the end? H. So that's what we have to mush together. 2 times 2 is 4. W times W is W squared. H is just single H, and we just write H. So 4W squared H. The one we skipped, the top right. What's being squared? Just H. There's no point writing H times H. I'm just going to come back to H squared. There's nothing to do for this one. There's no distributive property. There's nothing to square. So this one is already done. So you can write the word done, or you can write can't be simplified, or anything like that to give me an indication that you know it's already in simplest form. Okay? You could just rewrite it if you want. Okay, next page. We're going to do this problem together. Number 5. We're going to solve this equation right here for M. Okay, so there's a lot of crazy looking letters in this problem. Let me tell you that this equation is something that has a physical context. This F stands for force, and this equation gives you the force exerted by two bodies on each other. So for example, the Earth and the Moon have this constant tug happening, which is why the moon doesn't just fly way off into outer space. It stays kind of tethered to us, even though there's no like physical tether, right? It's because the Earth and the moon are pulling towards each other. This equation tells you the force that the Earth and the moon are exerting on each other, right? Has to do with some constant K, the mass of the Earth, the mass of the moon, and the distance between the Earth and the moon. So do some calculations and you can find what that actual force is. Okay, what we're going to do is solve this equation for m. Now we have lots of experience this semester solving equations, but I think that in every equation I've asked you to solve, there has been one letter, only one letter. This equation has many letters in it, and this is called a literal equation. And the word like literati has to do with letters, and that's why it's called a literal equation. It's an equation with lots of letters in it. And we're going to solve this thing for m. Okay, so m, little m, is the only variable. Everything else needs to move away from the m. So for example, this d squared on the bottom needs to get over to the other side. What's the opposite of dividing by d squared? Is multiplying by d squared. So I'm going to multiply both sides by d squared. Let me write that equation again. I'm going to multiply both sides by d squared. What happens on the right-hand side? The d squareds cancel. That's why we put it there. So then I'll just copy what's left. D squared times f equals k, little m, big M. Again, I'm going to circle the variable, which is lowercase m, which means everything that's near lowercase m needs to go away. So what do you see that's near lowercase m? It is capital M, and what else is near? Is k. All right, we have multiplication by k and capital M. What's the opposite of multiplying by km? Dividing by km. So we're going to divide both sides by k and capital M. K and capital M. What nice thing happens on the right-hand side? The k cancels, m cancels, and we're left with exactly what we wanted, which was little m d squared times f divided by k times capital M. Okay, so 2 words of advice on solving literal equations like this. Number 1, circle the thing that's the actual variable you're trying to solve for. I think it's really easy to get distracted by all these other letters. You got to really focus on what you're trying to solve for, which in this case was little m. We circled it all the way through. The other suggestion that I have, if you have no idea how to start on one of these crazy complicated literal equations, then start changing letters into numbers. For example, instead of f over there, I'll make it a 10 equals. Instead of k, 7. M is the thing I'm trying to solve, so I'm going to keep it there. Capital M, 3. D squared, 5 squared. How would you solve this equation for m? What might you do first? Maybe multiply both sides by 5 or by 5 squared. Probably multiply both sides by 25. So you start to think, oh, I'm multiplying by whatever's down there. Oh, I'm going to multiply by d squared. And so change it to numbers if you just can't get started. Don't guess, don't make up your own rules. Change it to numbers and then see if you can apply that to our general equation that we started with. Okay, number 6 will give you some more practice with literal equations, and then there's some geometry stuff on the next page. So see if you can get through that.